Hello and welcome to another LeetCode problem. Today we're going to be doing the problem of the day for July 6th, minimum size subarray sum. So you're given a subarray or given an array and you want to return the minimal length of a subarray whose sum is greater than or equal to the target, and if it doesn't exist, let's return 0. Okay, so for this first example, we are going to have an array of 2, 3, 1, 2, 4, 3. And the minimal length subarray that has 7 or more is this, obviously. There's nothing shorter than that. For the second example, pretty straightforward, 1, 4, 4. It's this or this. Either way, they're going to be length 1. And for the last example, we only have 8, 1, so we don't have no solution. So let's figure out how we would do this, right? So we're going to have this problem. Let's figure out how we do this for this example here. So we have a target, and we know our subarray is contiguous. So as soon as you know contiguous subarray, first algorithm you got to think of, sliding window. Is it possible? Easiest one if it is. Let's try to think about it. And in this case, we do have a condition, right? Like our subarray has to be greater than 7 or equal, and it has to be contiguous. So we can just keep a running total. So we can have a result. We're trying to minimize it, so let's just make the result infinity to start. And we're just going to make a sliding window, and we're just going to, so our algorithm is going to go like this. I'm going to show you. So we're going to start at the left, and we're going to keep going until we've matched the greater than 7 target. And so we're going to go like, take this number, we can keep going, 5, 6. So now this is our subarray here, this thing here. So the left is here, the right is here. So I'm just going to represent the left and the right with this line. The left is always going to be to the left of the line, the right will be to the right of the line. And so now what we're going to do is, once we actually have a valid subarray, we're going to shrink it as much as possible, but it has to still be valid. So our sum, we'll just call it our sum. Our current sum is, or just call it cur maybe. Our current sum here is 8. And so we're going to see if we can shrink it, and we're going to shrink it as much as possible to make it still valid. So if we actually get rid of this element, this wouldn't be valid, right? This would be 6, so we can't actually shrink it. So this is going to be our current subarray. And so this is length 4. So now our result is going to be updated to a 4. Now that we can't shrink it anymore, we're just going to keep adding to it. So we're going to add the 4. Now our current sum is 12, and we're going to try to shrink it as much as we can again. And so let's see how that would look. So we can get rid of this 2, right? So we can get rid of that. We could shrink it like that. Now our current sum would be 10, and we can't shrink it anymore. So our subarray would be 3, 1, 2, 4. And so that's also length 4, so that's the same as our result. Now we finally add this 3. And so the left is over here, the right is at the end. And so when we add the 3, our current sum is 13. Now let's try to shrink it as much as we can, remember, because we're trying to minimize the length. So we can shrink it, we can get rid of this number, now our sum will be 10. We can also get rid of this 1, now our sum will be 9. We can also get rid of this 2, and now our sum will be 7. And finally, we can't shrink it anymore because we are at the target. And so now this is going to be our subarray. So the left is here, and the left is here. It's not really a left, but you get my point. Left, right. And so now this is going to be length 2, so that's our result. So pretty straightforward problem. So we're going to write down the steps actually here. So let's make this text a little smaller. Okay, 1, 2-pointer technique. Okay, so keep adding to subarray until it's greater than or equal to the target. And then when it is, shrink from left as much as possible, but maintain validity, right? So it has to be greater than so sum has to be greater than or equal to target. And then finally record result and try to minimize our results. So we're just going to have like a min of whatever our subarray is in our current result. And then finally, if our result is infinity at the end, that means we didn't find any valid subarray, so then we can just return 0. So pretty straightforward problem. I think it's pretty similar to the last problem that I did yesterday. Very, very similar. So let's actually code that up. And so we're going to have a left, as always, for sliding window, sorry. And then we're going to have a result. We're going to make it infinity. We're trying to minimize it. Okay, and I believe, oh yeah, we need a current sum, right? So just current sum. We're going to make that 0. And so we're going to actually, like I showed in the other video, we can actually use the right as the index we're actually iterating through, because we have to iterate through all of nums. So we can just do this. Range nums. So you don't even have to initialize the right here. You can just throw it right in there. Okay, so what are we doing? So we are cur sum plus equals nums right. We are adding the value. Now, if it is greater, we're trying to shrink it as much as we can, right? So while, let's see here. So we need to shrink it as much as we can, but we don't want to shrink it too much. So I think what we could do is just have a while and a break loop. That would probably work fine. Okay, so let's do that. So while this is going to be cur sum is greater than target. So if this is going to be cur sum minus nums left. So if we can't shrink it, is less than target, right? If cur sum is, so it's actually also, by the way, that's actually in here. Let's do the checking for the result. We can definitely do that because we're trying to minimize our array. So we're going to check the result multiple times, but that's okay because you don't want to have an if statement outside, or you could do an if statement outside. Let's actually do the if statement outside, but anyway. So if the current sum minus nums left is less than target, that means, so if this is greater than or equal to target and the current sum minus nums left is less than target, that means we can't remove the left, so we can just break. And then otherwise we can remove the left, so cur sum minus equals. Now let's actually look what the target can be. And let's think about like an edge case as well. Like if the target is 1 and I think we might want to add, do we want to add that? Like the condition I'm thinking of is if we have like a one length subarray, but that'll never actually be in. Yeah, so if we do have a one length subarray that's greater than the target, but we don't want to remove that element. No, I think that'll be fine. Yeah, I think this should always work. But we'll test it out. We'll see if we have any edge cases. Okay, so anyway, so cur sum is gonna be minus equal nums left here, right? And then left plus equals 1. I don't think we have to check if the left is like past the right or anything. I don't think it can ever be, because like I said, if we have a one element array and our target is even 1, then we can never remove every single element. Okay, anyway, so now we can check in here. So if cur sum is greater than or equal to target, we have a valid array. Then we can do our result checking here. So as always, we can minimize the result. This is right, minus left plus 1 to get the length of the array. And then we can just at the end, so we don't need to do the right plus 1 because we're iterating through the array, but we do need to check if the result is infinity, and if the result is infinity, that means we didn't find a subarray. Okay, so let me just go over this one more time just to make it clear. So this is going to be like our right part of the sliding window. We're going to add the number, and then while the number is bigger than the target, we're going to try to minimize it as much as we can. But if this is the case, that means we can't get rid of the left element. Otherwise, we're going to get rid of the left element, and then we're going to increase the left element. Then we're going to check, is our subarray valid? And if it is, let's update the result. And finally, we can say return result if result does not equal float infinity. Else return 0. Okay, let's see how many errors we got. Can't wait for this one. You don't say. Oh, amazing. Okay. So this was actually good. So that's surprising. Okay. So let's actually think of the time and space here. And so, like I said, it's a sliding window. So these are pretty much always O of n, where n is the length of nums. And space, just like yesterday's problem, is O of 1. We didn't declare any extra space or anything. We just have some variables. But yeah, that's going to be it for this problem. Hopefully you liked it. And if you did, please like the video and subscribe to the channel. And I will see you in the next one. Thanks for watching.